Hello, people, and welcome back to another session. In this session, we'll be continuing our discussion from our previous session where we discussed how to calculate the various values of ANOVA table for a multiple linear regression problem statement. Now, today in this session, we'll be looking at the statistical inferencing side of multiple linear regression. Now, the statistical inferencing of multiple linear regression is slightly different from that of a simple linear regression. Let me explain why. In case of a simple linear regression, our initial static condition or null hypothesis was that there is no association between my independent variable and my dependent variable. So that association was represented through the slope of the line or the beta 1 value. This was our initial condition. Now, this was pretty much straightforward for simple linear regression because we had only one explanatory variable, and the slope corresponding to that is going to be the one determining the association. But here in this particular scenario, we have multiple independent variables, right? So the question that arises is that at a given instant, how are we going to do statistical inferencing where we have more than one explanatory variable? The answer to that particular question is that in multiple linear regression, our statistical inferencing will be done in two stages. The first stage of statistical inferencing is called the global F test. So let me write this down. For MLR, two-stage statistical inferencing. Okay. Stage one is going to be global F test. And stage two is going to be t-test on individual variables. So what is the purpose of this two-staged test of statistical inferencing when it comes to multiple linear regression? The purpose is that in stage number one or the first stage, what we are trying to determine is whether any of the independent variable have any association with my dependent variable. Let me reiterate. In the first stage, what we are trying to understand right at the onset is we are trying to predict, does any of the variables out of all the explanatory variables that we have, does any one variable at least have a association with my dependent variable? If yes, then I can go ahead and then I can figure out which out of the out of all the independent variables we have, which one actually has an association. But first I need to figure out whether at least one of the variables have any association. That is done using our global F test. So let us write down the null and alternative hypothesis for our global F test. So null hypothesis for global F test will be and my alternate hypothesis will be at least one beta I is not equal to 0. So out of all the variables that we have or all the coefficients that we have, we want to find out whether at least one of the coefficients is not equal to 0. That is done using global F test. So when it comes to F test or global F test, the concept remains the same. We discussed F test in great detail when we were discussing simple linear regression. If you have any doubts in that, you can go ahead and check that video out. But the concept of F test will remain the same. So now what we'll do is that let us go ahead and let us start doing this particular global F test on the existing sample example that we took in the previous session. So in the previous session, we calculated up till here, we calculated the F stat value for a model that was created with salary 1 as my dependent variable and age and height as my explanatory or independent variables. So this F stat that you calculated, this is the value of my F statistic. Okay, this is the value of my F statistic. Now for doing hypothesis testing or to check whether we have sufficient evidence to reject my null hypothesis or not, I need to compare my F statistic with the critical F value. Now for my critical F value, we saw how to calculate our critical F value using global F test. As I mentioned in my previous session as well, F test is always one-sided. Although in this given condition, we need to find out for any of the variables whether there is positive association or there is negative association. But F test, when doing F test, you have to solve it from the perspective of a one-sided test rather than a two-sided test. So with that said, let's move forward again. Each and every single one of these concepts was explained in simple linear regression. So we have to solve it actually. If you look at this statement below, is there a linear relationship between CEO's salary and their age and height? Calculate at 0.01 alpha level. 0.01 alpha level, which means my confidence level is 99% or 0.99. So I'll write 0.99. The degree of freedoms that we take in F test is k and n minus k minus 1. So k is 2, n minus k minus 1 is actually 97, which is n minus 3. So now you must be asking, where did I get this value 97? It's basically my residual df. Residual df is nothing but n minus k minus 1. And my 2 is my regression df, which is nothing but k. So I run this and I get a very small value of f critical, which is 4.83. Now look at my f stat and look at my f critical. Clearly my f stat is greater than my f critical, so I can reject the null hypothesis and I have sufficient evidence to show that at least one of the explanatory variables has association with my response variable. Now we will move on to the second step to find out actually whether age or height or both of them have association with my salary 1. And we'll do this using t-test. Let us go back and look at my summary table. My summary table gives me the value of age and it gives me the value of the t value of height already. And this particular t value needs to be compared with a with my critical t-value. Now, this critical t-value is going to be a double-sided t-value because this is t-test. T-test in this case has to be two-sided because we are finding evidence for my coefficients can have positive correlate, positive association or negative association. So for step 2, this right here, 99%. This right here will be 5%. Sorry, this combined, this two will be, these two areas combined will be 1%. So 0.5 and 0.5. So if this is my T critical, this is 0.5. So the area towards the left of T critical is 99.5%. So if I have to calculate T critical, I'll calculate it as QT. Now degree of freedom will be n minus k minus 1 and 7. T critical is extremely small, 2.627. And as we can observe from our summary table that both age and height have t values way beyond the critical t value. So we can surmise that both age and height have association with salary 1. So this is how you do a statistical inferencing for multiple linear regression problem. So reiterate, you use the global F test to measure or to observe whether any one of the independent variables have association with my dependent variable. Once that is established, then you go ahead and find out exactly which of the independent variable has an association out of all the independent variables. I hope this session is clear to you. And with this, we'll move on to our next topic in our next session. I would thank all of you all for watching. I'll see you all in the next session. Thank you.